Hey, seventh graders. So in this section, we're going to be talking about, or this week, I should say, we're going to be talking about different terms, combining like terms, using the distributive property, figuring out percentage of numbers, and there's something else in there too. There's a lot going on in just these two little lessons. So first thing I want to let you know is make sure you understand what terms are. So in math, terms can be a variable by itself. It can be a number by itself, like minus 15, or it could be a number attached to a variable, right? The thing that separates terms are plus and minus signs. So here in this example, we have three terms. What are those three terms? Well, we have 7x, 9y, and negative 15. If you don't see a sign in front of it, of course, it means it's a positive. When you see a plus sign, obviously that means it's a positive term. And when you see a minus sign, that means that term is a negative number. Now, the reason that these are three separate terms, we cannot combine these terms because they are unlike terms. So to have like terms, you have to have the same variable and power. A power means an exponent. If you don't see an exponent, it means it's an exponent of 1. So this is 7 times x to the first power plus 9 times y to the first power. And then 15, negative 15 is a constant, which just simply means it's not attached to a variable. So there are three terms. So in the term 7x, we call the 7 the coefficient. So when you have a variable, which means any number that represents a number in math, the whole number attached to the variable is called the coefficient. Like terms are terms with the same variables raised to the same exponents. The coefficients do not have to be the same. It's just a matter of the variables match and the powers match, or the exponents. It says constants like whole number 5, 3.2, and a fraction 1/2. These are like terms. So if there's no variable attached to any number, those numbers are like terms. So it says to identify the like term. So let's look at 5a. So 5 times a raised to the first power is like this term because it also has an a raised to the first power. Those are the only two terms that are like each other that have an a. Now let's look at the next variable of y squared. So 3y squared is like 6y squared because they both have the variable y and an exponent of 2. Then we have a constant. So 5 is a constant, and it is like negative 3, which is a constant because neither of them have variables, or excuse me, yeah, variables, correct. And then 3y is all by itself. There's no term that's like 3y. Then it says to combine or add these like terms. So if I have 5a and I want to combine it with negative 3a, I'm simply going to add or subtract those coefficients. So 5 minus 3 is 2, and a is part of my answer. Then we have 3y squared plus 6y squared. The y squared just means they're alike. I don't add those 2's, but I do add the coefficients. So 3 plus 6 is 9y squared. And then my other like terms were 5 combined with negative 3, which is positive 2. So we just combined our like terms. All right, what about these? So everybody pause the video, try to combine these on your own, and then turn the video back on and see what your answers are. Make sure you're right. So the first one, we have 9x. The second one, we're going to combine 5x to the third times 7x to the third, and we get 12x to the third. We also have minus 4x squared. And the other two like terms are positive 3y minus 2y, and that is positive 1y. Well, 1 times y is just y. So anytime the coefficient is 1, you don't have to write it because 1 times anything is whatever you multiply it by. 3 was, we have 3a minus 5a is negative 2a, and then part of my answer is 2b. There's nothing to combine it with. And then number 4, we have 2 plus 1 is 3a, because remember the coefficient is 1 plus 2. And then 2 plus 1 is 3b. And then minus 2c is part of our answer. So I hope you guys got all of those right. All right, now you cannot add unlike terms, but you can distribute unlike terms. So on the top, we can either add these two numbers together and get 5, and then multiply 5 times 5 and get 25, or we can distribute the 5 to the first number and then 5 to the second number, and we get 10 plus 25, which is also 25. So those two answers match. Now, like I said, we can't add unlike terms, but we can multiply them. So 5 groups of A would be 5A, and then 5 groups of 4 would be 20. All right, let's use the distributive property. 6 times A is 6A, 6 times B is 6B, and 6 times 3 is 18. And that's a final answer because now these are unlike terms and we can't add them. Negative 2 times 4 is negative 8. Negative 2 times 1a is negative 2a. Negative 2 times 3 is negative 6. And then we have to look at it and say, okay, well, here we have two like terms. That should be an A. I don't know. It looks weird. But we have negative 8 combined with negative 6 is negative 14. So our final answer is negative 2a minus 14. All right, let's do number 4. Example 4, we're going to distribute that negative 4. So we have negative 4x minus 4y plus 3x minus 5y. Now we combine like terms. So negative 1 plus 3x is negative 1x, or negative x. And then negative 4y minus 5y is negative 9y. And that is our final answer. All right, you guys, why don't you guys try these 4 problems and these 4, and then come back to the video and check your answers. So for example 5, we're going to distribute and we get negative 5a, and negative 5 times negative 4 is positive 20. Number 6, we're going to get negative 6a minus 6b minus 18. Number 7, we're going to do positive 8 minus 2a plus 6. We add 8 plus 6 and we get 14. So we have negative 2a plus 14. And then this one is negative 4x plus 4y plus 3x minus 5y, which is negative 1x minus 1y. If you have a 1 as a coefficient, you don't have to write it, but if it's a negative 1, you have to write the negative sign. All right, what's your final answer for these? I got 6d minus 18. Even though it's on the back, it's still multiplication. So we have 10 plus 2x plus 3x is equal to 10 plus 5x, because we have to add our like terms. Then we have 3a plus 3b plus 3c. Then we distribute, we have negative 5 times a is negative 5a. Negative 5 times 6 is negative 30, positive 5a. So then we're going to combine positive 5a minus 5a. The 5a's cancel, because 5 minus 5 is 0, and 0 a's is just nothing. So our final answer is negative 30. All right, what about these? Well, if you're going to multiply 3a times 1x, basically that all just gets put right together. So 3a times x is 3ax, and 3a times 2 is plus 6x. Those are unlike terms, so we cannot add them. So a times b is ab, A times 2 is 2A. A times C is AC minus 2A. Then we have two like terms. Positive 2 minus 2 is 0. So our final answer is AB plus AC. All right, we're going to multiply 4A times negative 2 is negative 8A. 4A times B is positive 4AB plus 2A minus 3AB. We're going to combine like terms. So that would be negative 6A plus 1AB. And then AB times C is ABC plus ABD plus ABE. And that is our final answer. All right, I hope you guys have a chance to pause the video and do these on your own. So we have 6AD minus 18A plus 2AD. So we have two like terms here. So we have 8AD minus 18A. All right, now we're going to multiply 4 times 2/3. So we're going to do 2/3 times 4, and we get 8/3. So 2/3 times 4x is 8/3 x. And then we're going to multiply 2/3 times 9. And we get 18/3, which is 6 plus 6. There's our answer right there. All right, the next one is 3AB minus 3AC plus 2AC. And then we have like terms. So 3AB minus 1AC. And that's our final answer. And then we have negative 5AB minus 30AC plus 5AB. What happens to our positive 5 and negative 5AB? They cancel, and this is our final answer. All right, now sometimes you'll have a situation where you have a negative sign in front of a set of parentheses. So basically, it's like you have to distribute a -1 to everything in the parentheses. If there's a minus sign in front of the parentheses, you have to distribute the negative sign or -1 to everything. So think of it as the opposite of 4x is negative 4x. The opposite of plus 6 is minus 6. And the opposite of minus 3x is plus 3x. And then we do have two like terms. So negative 4x plus 3x is negative 1x minus 6. All right, example 13, we're distributing the negative sign. So the opposite of negative 3x is positive 3x, and the opposite of plus 4 is minus 4. So the same thing is true with subtraction. Once you have subtraction in front of parentheses, you have to distribute that negative sign to everything. So the first one we bring down like we see it. Then we're going to write minus 3x, and then the opposite of negative 3 is plus 3. And then when we combine like terms, we have 5x minus 3x is 2x plus 7. All right, we're going to bring down negative 2m plus 3n, and then we're going to distribute the negative sign. So minus 5m plus 3n. So then we have negative 7m plus 6n. And that's our final answer. All right, now you guys try these 9, 10, 11, and 12, and I want you to send me a Canvas inbox and tell me what the answers are. 9 through 12. I want you to send me a message. All right, I'm making myself a note. I'm expecting to hear from the 7th graders this week of what these 4 answers are. All right, now you can, factor out. Let's look at both of these numbers. The very first one up here, we have 3x and we have plus 4. So you know how we were distributing the same number and we were ending up with an expression? Well, this is almost the opposite. Now we want to say, okay, well, what could we pull out of both of these numbers? What could we divide 3x and 24 by? Well, couldn't we pull out a 3 from both of them? Well, let's do that. What's 3x divided by 3? It would just be x. And what would be 24 divided by 3? What would be positive 8? And then to see if that's correct, we could try the distributive property. And when we do, we get back what we started with, 3x plus 24. So that means that these two expressions are equal. Let's look at this one here, the second one. What could we divide 4 and 18 by? Well, we could divide them both by a 2. So 4x divided by 2 would be 2x, minus 18 divided by 2 would be minus 9. So that is an expression equal to this. And the way we would check it, use the distributive property, make sure we end up with what we started with. The third one, what can we pull out? The biggest number is a 4. So 16x divided by 4 is 4x, and negative 20 divided by 4 is minus 5. All right, I hope you guys try the next two on your own. So we can divide everything by 1/4. So 1/4 x divided by 1/4 is x. And we want to know what is 8 divided by 1/4. Well, that's where we keep it, change it, flip it, and we actually get positive 32. Now, when we distribute the 1/4, 1/4 times x is 1/4 x, and then 1/4 of 32 is 8. So these are equivalent. What about this one? We can divide them both by 1/2. So 1/2 x divided by 1/2 is x, and 6 divided by 1/2 is 12, because you keep it, change it, flip it, so it's just 6/2. All right, now on this problem, we're going to go around this triangle. To find the perimeter, we add all the sides together. So we're going to add the top side of 3x plus this side, which is 0.8x plus 9, plus the third side, which is plus negative 2.1x plus 4, or I could put the whole thing. It doesn't matter. I just want to make sure you know that that is adding a negative is the same thing as putting plus, just minus. Let me just write it that way. I'll just write minus 2.1x. So now I want to combine all like terms. So I have 3x plus 0.8x minus 2.1x. So I'm going to do 3 plus 0.8 minus 2.1, and I got 1.7x plus 9 plus 4 is 13. So you're going to have a problem like that as well this week. All right, it says, so now we're looking at percentages. So we're kind of changing lanes, but this first lesson goes over all of this stuff, you guys, is crazy. So if a sweater goes on sale for 12% off the original price, what percent of the original price will the customer pay? Well, when you start with the original price of anything, you're talking about the whole price. That's 100% of the price, right? But they're going to subtract away 12%. So you're literally going to subtract 12% from 100% to realize that when things go on sale, you're paying less than 100% of the price. And in this case, you would be paying 88% of the original price. Okay, so are you paying 100% if something's on sale? No, you're paying less than 100%. If it's 12% off, you're paying 18%. All right, let's see what this one says. When you have to pay a sales tax of 8%, what percent of an item's cost will you pay at the cash register? So let's say you brought a candy bar and the candy bar is $2. Well, they're going to charge you 100% of that price plus 8% more. So when you get the cash register, are you paying only 100% of the price? No, you're paying 108% of the price, right? So you take the price item and you multiply it by 1.08, and that will be the total price with sales tax. Up here, since we're paying 88% of the original price, to figure out the sales price, we would multiply the sales price by 0.88, which is 88% as a decimal. All right, then it says if a sweater was originally $52, it's on sale for 12% off, what will a customer pay at the register, including 8% sales tax? So we would take 100% of the price. We're going to subtract from it 12%. So that's 88% of the price. And then we're going to take that price and we're going to find whatever this price is going to be. We're going to pay 108% of the sale price, right? So we're going to take 8% of the sale price. The sale price is going to be our, let's call this P. Let's pretend for a second we don't know what the original cost is. We're going to pay 12%, excuse me, not 12, 88% of the original price. And then when we get that answer, we're going to multiply it by 1.08 because that's taking that price, paying 108% of it. So now, so this would be an expression to figure out the total, the sales price with sales tax. So let's say our original price is $52 and we're going to find 88% of that amount of money. Well, $52 taken away 12%, 52 times 0.88 is $45 and 76 cents. Now that's the sales price. Then we're going to take that whole price, 100% of the sales price plus 8%, which means we're going to multiply 45.76 by 1.08. So $45.76 times 1.08. My calculator says 49.4208. Now, how do we deal with money? What's the farthest place we go with money? Well, we go to the penny, right? So whatever this number is, it determines what our penny's going to do. Is it going to stay a 2 or become a 3? So that means we're going to pay $49.42. That's our sweater that was on sale with sales tax. This is how much they'll charge us at the price register. All right, Sammy purchased a video game that was 15% off. So we start with 100% of the price and we subtract away 15% of the price. Then we have to pay sales tax on it, which is 7% in this guy's county. He said, let Y represent the original price of the game. Write an expression that can be used to determine the final cost. So if we started with 100% of our price and we take away 15%, that means we pay 85% of the original cost. Well, if Y is the original cost, we're going to turn 85% into a decimal and multiply it by Y. And then whatever that answer is, we're going to multiply it by this whole answer. So whatever number this is, we're going to multiply this whole number by 100 plus 7, which is 107%. And 107% as a decimal is 1.07. This is the expression we're going to use to find the cost of the game on sale with sales tax. That's the expression. And then the second question says, what if the original price was $42? So we're going to do 0.85 times $42. And then that whole price, we're going to multiply by 1.07. So let's do what parentheses first. We're going to do 0.85 times $42. So we're going to pay $35.70. That's the sale price of our item. Now that price plus plus our 7% sales tax, we're going to multiply by 1.07. So at the cash register for on sale and with sales tax, this is what my calculator says. Well, this 9 is going to turn that 9 into a 10, carry the 1, and I get 20 cents. So the answer, rounded to the nearest penny, on sale with sales tax, is $38.20. That is the answer. Wow, you guys, that was a lot, wasn't it? Well, I hope that helped. You might have to watch the video more than once so you can get all of those examples written down and so that you can understand them. So I hope you guys, it's hat day. That's why I'm wearing this, you guys. But anyway, I will talk to you guys later on during the week. And if you need me at all, please let me know. And you